Welcome to DC Economics. So we are going to speak about on how we can find the power rule for derivative. So a power rule is the rule that used to find the slope of a polynomial functions and any other function that contains an exponent with a real number. In other words, it helps to take out the derivative of a variable raised to a power or exponent. So under power rule, we tend to look on how we can deal with exponential values on the polynomial functions. So we apply different derivative techniques so as to solve out different problems by using the power rule. There are several steps that are involved in finding the power rule. The first step is to move the exponent down in front of the variable. Is to move the exponent down in front of the variable. And second, it is to multiply it by the coefficient. It is to multiply it by its coefficient. And third, is to decrease the exponent by 1. So if a given n is a real number, then derivative of d over dx such that raised power of n will be given as a function of, we take out n times x, that will be equals to nx, then n minus 1. So this is actually the principle that we apply under solving different exponential polynomial function by using, or derivative by using the power law. Let's look at an example. Find the derivative of x raised power of 2. Solution. From x raised power of 2, we take out the principle of derivative, that is any x n minus 1. So we take out 2 times x, it will be equals to 2x, then we take 2 minus 1. We raise power of 2 minus 1, the answer will be equals to 2x. So the derivative of x squared is equal to 2x. So it will be better now we look another derivative rule that we apply. For example, find the derivative of d over dx times x raised power 4 bracket. Solution. So when we use the principle, the same principle of any x n minus 1, so we'll take out 4 times x, then we raise power 4 minus 1. So the derivative of this particular function will be equals to d over dx raised power 4 is equal to 4x cubic. When you take out 4 minus 1, it will be equals to cubic. So it is equal to 4x raised power of cubic. So that will be the answer. But one thing we need to understand is that when we are solving different derivatives, there are some actual principles or rules, guideline that relies in solving different derivatives, problems or function. So, but the power rule tends itself to the following differential rules. So power rule, when solving calculating derivative by using power rule, there are some different reliable conditions. There are different reliable rules that we apply. The first rule is constant multiple rule, derivative constant rule, and the sum of the difference rule. So when we begin with the first rule, that is a constant multiple rule, let's take an example. And what is known as a constant multiple rule, of course, this rule says that. And what is known as constant multiple rule, the rule says that any coefficient in front of a variable will be multiplied the rules state that any coefficient in the front of a variable will be multiplied by its derivative. For example, d over dx times function of x is equal to c d over dx times function of x. It will be better in order to understand on how this constant multiple rule principle works. So find the derivative of 3x raised to the power 4 solution. When we take out 3x, then we minus 4 minus 1, the answer will be equals to, we take out 4 times 3, that is 12x cubic. So that will be the answer. Second, we have another rule that is known as derivative of a constant rule. Under what is known as derivative of a constant rule, this means that this is the rule, derivative of a constant, this is the rule that states that the derivative of a constant number, or we say that the derivative of a constant number, or the derivative is 0. So d over dx, this means that derivative of any constant number is equal to 0. For example, find the derivative of d over dx times 4. So when we take out the solution from this particular derivative, the answer will be equals to 0. Since when we take out 4, then we minus, we raise power of 0. The answer will be equals to 0 times 4, then raise power of 0 minus 1. So the answer will be equals to 0 times x raised power of negative 1. So automatically the answer will be equals to 0. So any derivative of a constant, its answer is equal to 0. It will be better now we look another reliable rule under derivative, which is known as derivative of the sum in different rules. Under this kind of rule, so the derivative of sum and different rules given as, for example, d over dx, this is the function of x plus or negative gx. So this will be equals to d over dx, then function of x, then plus or negative d over gx, as we observe. For example, we are required to find out the derivative by using the power rule from the given function. Suppose we have 3x raised to the power 5 plus 4x raised to the power 4. So the derivative of this function will be equals to, we take out, it will be equal to 3x raised to the power 5 minus 1 plus 4x, then 4 minus 1. So when we apply the derivative of this particular function, the answer will be equals to 3x, then 5 minus 1, that will be equals to 4. Then plus 4x, then 4 minus 1. So the answer will be equals to 15x raised to the power 4 plus 16x cubic. So the derivative under some different rules of the function 3x raised to the power 5 plus 4x raised to the power 4 will be equals to 15x raised to the power 4 plus 16x raised to the power cubic. So that will be the answer. So after understanding that, let's come and look on how we can find the derivative by using the power rule for a given fraction function. But also before that, it must be better we talk about also the extended power rule. For example, you're required to find the derivative by using the power rule on a given functions. Suppose we have 2x raised power of negative 10 plus 7x raised power of negative 2. So when you find the derivative of this function will be equals to 2x raised power of 10 plus 7x raised power of negative 2. We take out 2x raised power of negative 10 plus 7x raised power of negative 2. So when you apply the first order derivative of this function, the answer will be equals to 10 times 2, that is negative 20x raised power of negative 1. Then minus, we take out 2 times 7, that is 14x raised power of negative 3. Since we take out negative 2 plus 1, that will give you negative 3. So that could be the answer. Now without any doubt, now let's discuss on how we can find the derivative under a given fraction functions. So this is the power rule of a fraction. Suppose let's look at an example. Find the derivative of the function of x, that is 1 over x. So if you decide to find out the derivative by using the power rule, first of all we need to transform the equation into an inverse. This means that we transform the equation to the another form. So we take out 1 over x. Then when we transport it into another form in inverse, that will be equals to x raised power of negative 1. So if it will give out x raised power of negative 1, now we apply the derivative on that particular function. So when you apply the derivative now, is where we take out x, negative x, then negative 1 minus 1. The answer will be equals to x2. It will be equals to it will come now to be negative x raised power of 2, then over. So after taking that, let you take out the exponential. Take out x squared and put into the denominator side. Then take out x, that is negative 1 over x raised power of 2. So that is how we actually solve that particular function. It will be better now we go quickly through the last example. Find the derivative of d over dx, then 1 over x raised power 4. From this particular function, we are first of all we transform the function to inverse. That will be equals to x raised power of negative 4. Then we apply the derivative. It will be equals to negative 4x raised power 4, negative 1. So the answer will be equals to negative 4x raised power 5. So when we apply the power rule, we need to take out x raised power of negative 5 to the denominator side. So it will be equals to negative 4 over x raised power 5. So that will be the answer. So welcome to DC Economics. Don't forget to subscribe and watch on other videos. Bye bye.